Okay, it's been a while since I made a video, but just wanted to go over, make sure that you had a few examples here on YouTube. So the first one, you have to do power to a power. So 2 to the third is 8, m to the third power is m to the ninth, and n squared to the third power is n to the sixth. And then the bottom I just rewrote, and now all I really have to do is reduce. 2 goes into 8 4 times, goes into negative 18 negative 9 times, and then I'm going to think about what cancels out. It's looking like I have more m's and n's on the top than I do on the bottom. Alright, I have 4 more m's on the top than I do the bottom, so there's going to be 4 left, so all 5 of those are gone, and then there's going to be 4 left, and then all 4 of these are going to cancel out, and there's going to be 2 of these left, so that's n squared. Okay, so that's not that much different. This one here, we can't just do the, we can't cross out the y's squareds because we have addition and subtraction. Up here, this is all multiplication, so we were allowed to just eliminate as we went. Some people are coming down here and they're saying, okay, y squared and y squared cancel out, but that's not the case. Whenever you have an addition or subtraction, you have to actually factor out of both terms up top. So when I look at that, I think I can pull out a 5 and a y out of both of those. You have 2 times y, or 2y. Just think about it. 5y times 2y gives me the 10y squared. If I pull a 5 and a y out of that, I just only have a 3 left. Think about it. Do the distribution and see what you got. This one here, I can pull a 5y out of both of them, or 5 and a y out of both of them. This one's going to be 7y, and this will be minus 1. Alright, now, I've pulled a 5y out of both of them, and 5y divided by 5y is now, 1. So, this is multiplication here. Whenever we have multiplication, we can do this cancellation. And that's my final answer. Okay, so you want to rewrite it, but I can rewrite it. There's your final answer. Okay, so this one here, there's a lot of different ways that you can think about this, because we're used to seeing the difference of 2 squares where we have v squared minus 25. Okay, we're used to seeing it like that, and it's pretty easy, but we still have the difference of 2 squares. It just happens to be flipped around. So when you see that, I would write it as that's like a negative v squared, and this is this is a positive 25. So when I flip it around, I have to write it like that. And then this is going to seem kind of weird, but I want to make it this look like that. Okay, and I can do that by factoring out a negative 1. I get that this is not negative, but if I can factor out a negative 1 out of this, it's going to turn this one negative. So, oops, that's supposed to be squared. So, think about this. If I distribute a negative 1 to this, I'll have negative v squared and positive 25, and that's what I have here. But I'm going to be able to actually factor this as a difference of 2 squares and just leave the negative 1 out front. Okay, this here, I'm running out of room here, but as you can hear my dog barking upstairs, we're just going to figure this one out by just your straight factoring, guess and check method. If you think about it, this one works. Okay, hopefully you can see that. It's a little small. But you notice that when I FOIL this back out, I get that. So it's just straight factoring. We have to get better at that as we work with this. But this here, since it's a difference of 2 squares, you're going to have v plus 5 and v minus 5. That's the top part now. And the bottom part was 3v plus 2 and v minus 5. And you see that we have a binomial that's exactly the same, so those are going to cancel out, and our final answer is that. Now again, these v's do not cancel out because we have addition here. Alright. Okay, try not to run out of room here. This one here, you know, when I look at it initially, I think I got an end of the fifth, I have end of the eighth up top, you know, and I feel like I can kind of rearrange things because this is all multiplication. You know, I've been having you guys do this, and just think of it as this is all, everything up here is up top, everything down here is on the bottom, and if I do end of the fifth times n squared, I'm just rearranging it and I'm going to put end of the eighth over here because I feel like those two can cancel each other out. Alright, so all I did was basically switch the bottom ones. So I can think about this canceling out, and I also see this expression here being able to factor something out of that. Alright, so end of the fifth, I'm going to leave that there. I can factor out an n out of that top expression. See, I'm using up a lot of space, okay, so don't be afraid to use a lot of your scrap paper and you know, spread things out so you can keep it nice and neat. So n minus 6, n minus 6, when I factored out that n, it gave me this n minus 6, and those are going to cancel out. And same thing here, I've been talking about this, I can go ahead and take care of this now. There's 5 n's here, there's 8 there, so all 5 of those are going to be gone. There's going to be 3 left there. So really the only thing that's left is there's a single n up top, this one, and an n cubed. Now, that can be taken even further, right? This is end of the first, so there's one n here that's completely gone, and that's going to cancel out another one of those. Now when everything is gone out of the top, it becomes a 1, because think about it, and then so you have 1 over n squared. Okay, a few more here. Alright, number 11, and I believe I'm doing 17 here. 11 is multiplication, but like I said, basically make this one problem, or you know, one long bar, and yes, we do have multiplication. But let's just go from here. So, you know, this is a I see this is a binomial. This is a trinomial. This is a quadratic. It's probably going to be factorable. Here I just have a 5x squared kind of by itself. It looks like I can maybe factor out a 2x out of this expression. So let's go ahead and do that. Let's factor that part first. We'll also factor this. Let me factor a 2x out of that. So that would be 3 plus x. Think about it, if I FOIL that back out or distribute it back out, I would get that. Rewrite that part and rewrite that part. Alright, so let's look at this trinomial. I need two things that multiply to negative 24 that add to positive 5. That looks like negative 8 plus 3. Think about it. Multiply negative 8 and 3, you get negative 24. You add them, you get negative 5. So, if you look at this, this is 3 plus x and this is x plus 3. Same thing. Okay, so I could write this as x plus 3, because you can, you know, rearrange addition. Alright, so that's not a big deal. Now, you might want to do the same with these two. You might say, well, x minus 8 is the same as 8 minus x, and that's not true. Okay? So, let's rearrange this. We get put the 5x squared over the 2x. Sorry about that. And we have x minus 8. So, just make sure I'm still on the camera. So, I have 5 halves here. I can't reduce that. But I have 2 x's here and 1 x there. So I get 5x over 2. I have 8 minus x, x minus 8. Trying to think here. If I factor out a -1 out of this one, okay, so let's do this. 5x, x minus 8, that's up top. If I factored out a -1 out of that, this would become -8 plus x. Okay, and when I rearrange that, hold on, buddy. My son's asking me. I get -2, and when I go to rearrange that, that's x minus 8, and then that's going to cause that to cancel out. So we're playing around with the negatives a little bit to make things match up, and that would be our final answer. So 5x over, you can put the negative sign out front, it doesn't really matter, and we're there. Come on, buddy.
You know,
I'm making a video right now. Alright, so my daughter made a cameo. What's up, buddy?
Avery floated a cup at Mommy.
That's not good. Okay, will you go back upstairs? I'm almost done. Okay, this one is division. So we have to invert the second fraction and turn it into multiplication. I'm going to rewrite. This is s plus 4 squared. So I'm going to write it twice. And I'm going to invert the second equation, or the second fraction. Okay, and I turned it into multiplication. So division into multiplication, that's a standard, you know, what you have to do when you divide fractions. So it looks like I have two trinomials, quadratics, that I have to factor. So that's not that big of a deal. The bottom one's already factored. Looks like I have to factor down here, and that's a single binomial there. So let's start with the easy one. Two things that multiply to 25, positive 25, but add to -10 here would be -5 and -5. I know those s's kind of look like 5s. Sometimes they put a little dash mark there or whatever, but that's s minus 5. And then this is 2s squared minus 7s minus 15. There's only one way to get 2s squared, that's 2s times s. So you got to play around with this a little bit. There's not too many factors of -15. So I'm thinking about this. I have -3 times 5, -5 times 3, 15 times 1, 1 times -15. So I bet it's one of those two. That they don't really like to do the ones that are real far apart. So I need -7 in the middle. So if I look at this, it looks like if I make, think about this, 2s times -5 is -10 plus 3. -10 plus 3 gives me -7. So now, remember, this is multiplication, so this is, everything's on top, you know, together. It's all it's multiplication in between everything. So I can go ahead and start eliminating. So I have an s plus 4 and s plus 4, s minus 5 and s minus 5, and that looks about, that's everything I can cancel out. So I have 2s plus 3 on top left, s plus 4, and s minus 5. That's my final answer.